Assalamu alaikum students, how are you? Today we will discuss why real gases deviate from ideal behaviors. We all know about the kinetic molecular theory. Kinetic molecular theory basically explains the behavior of most of the gases under ordinary conditions. Basically, this theory was present for ideal gases. Most of these points are related to the real gases. However, two of the postulates are useful approximations and that do not reflect the following reality of the gases, which are the main causes of deviations from ideal behaviors. Basically, one point in the kinetic molecular theory which cause deviations from deviation of real gases from the ideal behaviors, which was also the reason for the van der Waals equation in volume correction. That was the actual volume is negligible as compared to the total volume of gas. Basically, gas particles are not the points of mass, but the volume is determined by by their size of their atoms. And basically, if gas molecules have atoms, the atoms have the mass, having bonds have a length, they have also direction, so they occupy some space, so we cannot neglect the actual volume. We explain grammatically this concept. For example, that is the container, that is the boundary of container in which gas molecules are wandering. If we apply a force, if we force these molecules to compress, and in highly compressed state these molecules occupy very little space as compared to this total volume of this container. As compared to this total volume, this volume which is actually occupied by the gas molecules can be ignored, can be negligible for the ideal gases. But in reality, it doesn't happen, because in reality, for the real gases, the actual volume, that is also known as excluded volume, effective volume, cannot be neglected as compared to this total volume of the container. That's the point which was the main cause of the deviation, one of the main cause for the deviation from the ideal behavior. Other ones, there is no force of attraction or repulsion among the gas molecules, but in reality gas molecules can attract each other or can repel each other. Okay, so real gases are polar or non-polar. The polar gases can attract each other and non-polar gases may repel each other. Okay, these are the 2 points of the KMT which was the major cause for the deviation from ideal behavior. Basically, at ordinary condition, relatively high temperature and low pressure, most gases exhibit nearly ideal behaviors. If temperature is very high and pressure is very low, the real gases show ideal behavior. Why? Basically, at higher temperature, kinetic energy of gas molecules is very high. The gas molecules are away from each other and there is no force of attraction. There is no force of attraction between the gas molecules, so they fulfill the requirement of this point, the attractive force. There is no attractive force between the gas molecules. If we have a low pressure, Same will be happen at low pressure, because at low pressure gas molecules widely separated from each other, and they have no force of attraction between them, so they show the ideal behavior. Okay, even at STP, standard temperature and pressure, gases deviate slightly from ideal behavior. We see in the table, for example, helium is the molar volume is 22.732 at its boiling point. The boiling point is slightly above the critical points, critical temperatures. The boiling point of helium is minus 268.9 at this temperature. At its boiling point, helium occupies the 22.732 molar volume. That is very close to the molar volume for ideal gases, that is 22.414. Okay, same for hydrogen, neon, argon, nitrogen, oxygen, carbon monoxide, chlorine, ammonia. These are the boiling point of these gases. These are the molar volume. These molar volume very close to the molar volume of ideal gases, that is 22.414. Okay, the real situation which caused the deviation from ideal behavior under the extreme condition. What was that extreme condition? That's the low temperature and high pressures. At low temperature and high pressures, if we wanted to explain these conditions, why gases deviate at low temperature, why gases deviate at high pressure, the reason is that at low temperature, gas molecules are come close to each other. They have a stronger force of attraction or stronger force of repulsion between the gas molecules. If the gases are polar, they have stronger force of attraction. If they are non-polar, they may have repulsive forces. They deviate from the kinetic-molecular theory postulates. Same happen at the high pressure. When we apply the very high pressures, the gas molecules are forced to come close to each other to form force of attraction or force of repulsion. So at very low temperature and very high pressure, gases extremely deviate from the ideal behavior. And to explain this deviation, we will see the compressibility factor inshallah in next video. We will understand what is the compressibility factor, which was calculated from general gas equation.